Welcome back to another Sunrise 2.x tutorial video. Today's topic of discussion will be on mastering and how to create your own mastering Sunrise application. So let's start by discussing the principle of mastering. The principle of mastering is to give the robot its mechanical zero, or a reference point for each individual joint. On each LBR joint, there are three main magnets. Two of the magnets are located at the minimum and maximum joint limits for the axis. The third magnet is located at the zero position of the joint and has a stronger magnetism than the joint limit magnets. During the mastering process for a joint, the Hall effect sensor rotates around the joint and initiates a search process by moving away from the nearest joint limit magnet in search for the zero magnet. Once it finds the zero magnet, it starts the recording sequence by first moving away from the found zero position, then stopping, and then with a constant velocity, it moves past the zero position and records the zero. Once the axis zero is found, the axis position is read relative to the zero magnet. Note that the search algorithm for the zero magnet for mastering is continuously being improved and may differ between Sunrise build versions. Attentively, this procedure is for Sunrise 2.6.5. Let's talk about a few recommendations or things to look out for when mastering. So the first thing to look out for is when you're mastering, if the search process begins rotating in the wrong direction, like towards the joint limit, then the mastering must be stopped, as a joint moving past the joint limit in search for a zero can cause significant damage to the robot. For example, it could bind the internal cabling and could pull a plug or actually pinch the cabling inside. One recommendation that we do have is that there is no specific start position per se. However, it's recommended to always master in the same pose, since different positions can affect the readings when mastering. This could be likely attributed to gear sag. So if you're running an application and you want the best precision with the robot, make sure that you're always mastering in the same position and that your program is running off of that mastered position. This will give you the best results for precision. Now that we've discussed the principle of mastering, let's go ahead and touch on how we can actually master the robot. There are two main ways to master the robot. The first way is through the smart pad that's connected to the robot controller. This is a great solution for mastering the robot during development, as it's very easy to access. The way that you can master through the smart pad is clicking on the robot tile on the smart pad, then clicking on the mastering tile, and then perform mastering and follow the instructions at the bottom of the smart pad. However, outside of development, there is a much better way to master the robot, and is the preferred way. This is through the IMasteringService interface, and it is the ideal solution for mastering the robot in the active field. There's no need for the smart pad since the mastering is actually carried out programmatically. So let's quickly walk through an example on how we can actually use this IMasteringService interface to master the robot programmatically. So we can start off by creating a new Sunrise application, a new robotics API application. We'll just call it IMasteringService Example. Before we start anything, I'm just going to quickly refactor this robot name to something a little bit more sleek. I'm also going to inject the IMasteringService interface and just call it Mastering Service. Additionally, I'm also going to inject the iTask logger, just so that our logging messages will be a little bit cleaner. So this IMasteringService interface has a few different capabilities. The first one is to actually invalidate the mastering on each joint or on a specified joint. So if the robot is mastered and you want to invalidate a mastering on a joint, you can use this method. We can also check to see if that joint is already mastered, and if it's not mastered, we could actually just go ahead and master the joint. So these are the three methods that we can leverage in the IMasteringService interface. So let's create a quick application. In this application, I want to check to see if the robot is already mastered. And then if it's not mastered, we're going to go ahead and try to search for which joint is not mastered and go ahead and master it. So let's start off by just checking to see if the robot is already mastered. So we can say if the robot is mastered, then we can go ahead and just log that the robot is mastered. And we can return. Since the robot is already mastered, there's nothing to master. Now, if the robot is mastered returns false, then that means we do have something that needs to be mastered. So we need to iterate through all of the joint count on the robot. So we can say for int joint, and we'll set it equal to 0 since this will be a zero-based system. We're going to loop through all of the joint counts. So we can say robot.getJointCount. And then we're just going ahead and increment each joint individually. So the first step is we need to check to see if the mastering for that joint is valid. So let's go ahead and say if, and use our mastering service object to use the isJointMastered method. We passed in our joint variable, and now if it is mastered, well, we can just continue to the next iteration because there's no point in trying to master the joint because it's already mastered. Now, if this returns false, we don't want to continue to the next iteration. We want to actually try mastering the joint. So we can say MasteringService.masterJoint and pass in our joint value, and we can go ahead and log what actually happens. So if we actually get true, then that means the joint has been mastered. So let's use some string concatenation to give our user a message. So we can say mastering joint. We'll pass in which joint it is, and we'll add 1 to take it out as 0 base, so it makes it a little bit more user-friendly for the person reading the smart pad. And we'll just say it was successful. Now, if the mastering failed, we can go ahead and repeat the same log message, but just say that it failed. So as a recap, we start our example. We check to see if the robot is mastered. If the robot's already mastered, we're just going to go ahead and return. If the robot is not mastered, we're going to loop through all of the joint counts on the robot. We're going to check to see if each joint is mastered individually. And if it has been mastered, we're just going to continue to the next joint. If it hasn't been mastered, we're going to go ahead and try to master the robot, master that specific joint. If it's mastered, we'll just print out that mastering J, whatever joint it is, was successful. And if it wasn't successful, then obviously mastering J, whatever joint it is, failed. Now, if you were to try to run this code on the robot and your robot is actually mastered, this code would run perfectly. However, if you try to unmaster a joint and then run this code on the robot, you would notice that you would actually run into a few different issues. And that's because we need to tell the application that it's okay to run without a mastered robot. To do this, we need to add an annotation before our class. So we can say MedApplicationCategory, and we need to check the mastering and set that equal to false. By putting this annotation there, now when we run this application without a mastered robot, it will not check the mastering, in which then we can actually master the robot in the application. Thank you for listening in on this Sunrise tutorial series on mastering, and this will now conclude this tutorial video.